All right, we're starting 2-2 angle relationships, and we're going to skip past the warm-ups here and jump into complementary, supplementary, and perpendicular. So on your notes, you should be on probably page 10, and it should start with 2-2 angle relationships. So complementary and supplementary angles. So complementary angles are two angles that with measures that have a sum of 90 degrees, and supplementary angles are two angles that have a measure of a sum of 180 degrees. So that's what you're going to be filling in on there. So now we'll have some more down below that you can fill in with those definitions, but there you go. If you want to pause it, complementary, two angles with measures that add to 90. Supplementary, they add to 180. So here's a slide about complementary. So that complement. Complementary are the ones that are going to add to 90. So you're going to see that like that 23 plus 67. 67 plus 23 equals 90. But they don't have to be adjacent angles like this. They could be angles that are completely not related to each other, and they could still add together to equal 90, like this 30 and 60 degree angle that are completely disconnected. Now look at some supplementary angles, and supplementary angles add up to 180. And again, they could be connected and form a linear pair, like over here, or they could be completely disconnected and still add to 180. Either way, they are supplementary. So the think about it here says a linear pair is always supplementary, while two supplementary angles are sometimes a linear pair. So if we look at that, look at this linear pair, always supplementary. But these ones, not linear pair. Okay. So our first example that we've got here, find the measure of two complementary angles if the measure of the larger angle is 5 more than 4 times the measure of the smaller angle. What I recommend with this is you draw yourself an example. So two complementary angles. I like to make them into adjacent angles. You don't have to. I like to. So I'm going to do this. They say that there's going to be a larger and a smaller. So I put them there, make them a right angle. Okay, and they say the larger angle is 5 more than 4 times the measure of the smaller angle. So I'm going to break this apart in here. The larger angle is 5 more than 4 times the measure of the smaller angle. So what they're saying is that the larger angle is based off the size of the smaller angle. So we're going to give the smaller angle a size. We're going to call it x. We're going to put that in there. We're going to say this one is x. And the larger angle is going to be 5 more than 4 times. So 5 more means we're adding 5. And 4 times means times 4. So we're going to take x times 4, 4x, and then we're going to add 5 to it. That's what we get right there. But that's not done. That is the hardest part of this. But we still need to go back and figure out what they want us to do. We need to find the measure of the two complementary angles. That is our goal. So in order to do this, we know that the two complementary angles must add to 90 degrees. So that's what we're going to do. We're going to say that 4x plus 5, that's angle 1, plus the other angle, angle 2, must equal a total of 90. That's the rule of complementary there. And that's something we can solve. So we simplify, we get 5x plus 5 equals 90. We're going to subtract that 5, so you get 5x equals 85. And then we're going to divide. So x equals, I believe that's 17. It's always a good idea for Mrs. Cruz to grab her calculator, because when she starts doing, oh, I don't need Outlook here. Goodness gracious. My calculator, wrong blue app. There we go. So 85 divided by 5. When I start doing math in my head, who knows what we're going to find out. And that is not what they want us to solve, though. They didn't say find the measure of x. In fact, they didn't even tell us x or tell us what variable. They told us to find the measures of the two complementary angles. Okay, but we found out what x is. That's good. Oh, that was a terrible box, though. So we're going to plug that in. We're going to plug that in there and into there. So we know that the smaller one, the smaller angle, is x, which means it's 17 degrees. The bigger angle must then be 90 minus 17, which is going to be 73 degrees. Or you could do 4 times 17 plus 5, which would also give you 73 degrees. Either way is fine. Both are a good solution. Let's go down and make sure we solved it correctly. 17 and 73. Woohoo, go team. Okay. Okay. Now let's think about this one. Adrian claims that if two complementary angles are both acute, then a pair of supplementary angles must both be obtuse. Do you agree? Explain why or why not. Think that over. Pause and think it through. I love that question. I hope you decided that it's not true. I hope you can explain why. Okay. Now, this one, mine says example on it, but this is supposed to be your practice. The difference between the measures of two supplementary angles is 18 degrees. The measure of the smaller angle is what? And the measure of the larger angle is what? Go ahead and practice. And pause me here. Okay. Did you get that it was 81 and 99? If not, go ahead and call a teacher over and ask what went wrong. Talk to your neighbors, see what they did. This one will definitely be an Alex topic that you'll need to practice, because this is something that is a standard and we need to know how to do. All right, let's move on. All right, perpendicularity is the next one. Line segments or rays that intersect at right angles are perpendicular. Here's the word you need in that fill in the blank. Perpendicular. Segments or rays can be perpendicular to lines or other line segments and rays. The right angle symbol indicates that the lines are perpendicular. So what they're saying is it doesn't have to be just lines that are perpendicular. I know we've seen this, and here's that symbol that we're talking about. You have one of those in front of you, but it could also be segments that are similar at 90s. It could also be rays that are at 90s, which of course form angles. So we get all kinds of perpendicular. Okay, Perpendicular lines intersect to form 4 right angles. So once you get 190, of course all 4 of them are 90, which we can prove by the law of vertical angles, right? Because then this one would be 90. And then the law of linear pairs, this would be 90 because they both add to 180, and then 90 over here. So yeah, all the way around. Form congruent adjacent angles, all kinds of things. And I think that's what they're proving down here, is that these are equal because of linear pairs. Because if there's a line 180 degrees, they must both be 90s. There we go. And you can do that the whole way around. Okay. So in this one, a tangram is a puzzle consisting of 8 flat shapes called tans, which are put together to form images. Find the values of x and y such that AD and EC in the tangram are perpendicular. So if they are perpendicular, what do these angles have to look like? That's the question. Well, that would have to mean that this is 90 in there. That's 90, 90, and 90, right? All the way around. So where would be our easiest thing to solve, right? What would be? Probably starting down here is where we see. Could probably set that 3y plus 15 equals 90. We could solve that pretty easy. But what else could we do then? If we know that this is all supposed to be perpendicular, then what would we know about these two? Well, we would know that they are congruent. We would know that they are 45-degree angles. I think that's probably what they're leading us to. Probably they're leading us to that they add to 90. Right now, we're not supposed to assume that they're equal. We can't assume that. Remember, we can't make assumptions. So they probably want us to say that this and this are vertical angles. We haven't talked about that yet. But if you have, oh, that was terrible. 2 intersections. Remember that this and this are equal because of vertical angles. Remember? Well, even if this line is up through there, you can still do vertical. You can take this one plus this one to equal this one down here. That's okay too. And that's what we're going to do. Once you can solve this one, which we already know it's 90, you could then say 7x plus 10 plus 8x plus 5 equals 90. And you can solve for x then also. So once you know that it is for perpendicular, you can solve for all those values. So there we go. They've got that one. And they've also got this one. So now you go down and you solve this one. This is our practice. Go ahead and pause me. Okay. Did you get that x was 12 and y was 23? I hope so. All right, now we are going to talk about assumptions. I just mentioned the word assumptions, and now we're going to drill down a little bit further. In geometry, figures are sketches that are used to depict a situation. And I want you guys to really highlight this on your notes. They are not drawn to reflect total accuracy. They are not perfect and they are not accurate. Certain relationships can be assumed, most cannot. Okay? So some things can be assumed, some things cannot. And what we find is that sometimes we make too many assumptions. Be careful. All right. So let's look at what this means. If we look down here, if we look at this example right here, in this one, things that we can assume. All points and lines shown are coplanar. You can always assume that if you've been shown this, that they are in the same plane. Always. Always in the same plane. Unless they draw out planes like that, and then they start drawing a line that's outside of the plane like that, you can assume that any lines drawn are drawn in the same plane. Okay? Always. G, H, and J are collinear. So the fact that they are on a line that appears to be straight, it is straight. It is all together on the same line. Okay, HM, HL, HK, GJ, they all intersect at H? Yes, they do all intersect at H. They are all meeting up right here at the same point. You can assume that H is between G and J. It's a pretty good assumption that it's between here and here. Yep. Okay, L. Oh, brought back too much. L is in the interior of MHK. You can assume that angles that appear to be less than 180 are probably less than 180, so that this point is an interior point. You can assume that G and J are exterior points to that angle. Okay, okay. GHM and MHL, those ones are adjacent angles, that they do share a side. So yes, when you see a ray like that, you can assume that it is a shared side to those angles.
Lunch C or 6C lunch students, come on.
All right. You can assume linear pairs. So when you see, let me get a highlighter instead, GHL and LHJ. Since we know that this is a line, any of these rays coming off of there are going to create a linear pair with angles. That's fine. This angle and this angle are a linear pair. Absolutely. Then you can assume from that, let's say here, JHK and KHG. Yes, those are supplementary. Absolutely. Therefore, any of those linear pairs that we get, let me see how straight we get, any linear pairs are going to be supplementary. We can always assume that. So, straight lines, angles off of them, you can assume 180. That's okay. All right. So it can be assumed. Straight lines, supplementary, adjacent angles. If you want, you can screenshot this, add it right into your notes. Okay. Things you cannot assume, and these are the ones that get us in trouble. And these are not a total list of statements, but these are things that I see pretty frequently. Lines that appear perpendicular may not be perpendicular. Guys, I can't highlight this enough. Just because it looks perpendicular doesn't mean it is. I see this all the time. All the time. I see like a triangle that looks like this, and I will see students tell me all the time that that's a 90 degree. But where does it tell me that it is? Where? It doesn't tell me. Unless it has that symbol there, we don't know. Okay? You don't know. So you have to be told. Okay? Angles that appear congruent may not be congruent. Absolutely. Unless they make this mark, those aren't congruent. Unless they tell you that this one is congruent to this one, they're not congruent. You may not assume. Appear is not enough. Not enough. Segments that appear congruent may not be congruent. So just because GH and HJ look congruent is not enough. Appear is not enough. Okay, a list of statements that could be assumed is not a complete list. There are more special pairs of angles than those listed. There's lots of ways that these can get you tricked. Don't fall for the tricks, okay? All right, so let's try some. Because points of intersection can be assumed, you can identify vertical angles. So, because it shows that B is in the middle of these two, you can know vertical angles are equal. So you can know those are equal. You can know that these are equal. Always. That's an assumption you can make. Because linear pairs can be assumed, you can always apply those characteristics. You can always apply 180s. So to that list of assumed things, you could always add vertical angles and linear pairs. Okay. Okay. So from this drawing, can you know that CE and CF are opposite rays? Let's go look. CE and CF. CE, are CE and CF opposite rays? Absolutely. That's a yes. Can we know that BCG, let's find BCG, angle BCG and KGC. Did I do this wrong? Yep, I did. Do it in order. BGC and KGC form a linear pair. Do they form a linear pair? They make a line and a pair. Yes. Okay. ABJ and CBG. Okay, do they form vertical angles? Right there and there? Yes. Absolutely. BCG and DCF. All right. Are those intersecting lines? No. Absolutely not. Those are not opposite angles. Those are not vertical angles. That's a no. They are not congruent. They are not opposite each other. They appear congruent. Let's look at those. These appear congruent. They look like they are. But there's no proof that they are. They're not vertical. They're not told that they're congruent. We do not know. BE, segment BE, and IF. Look at that. That's line IF. Is line IF congruent to segment BE? No. Hex no. All right. EBC and GBC are complementary. They do appear to be 90s, but appear. We don't know for sure. That would be an assumption. ICH HCD are adjacent angles. Yes, they share a common vertex and a side. BC, segment BC, is an angle bisector of ECG. It does appear to, but we don't know. Okay? Whenever we're making a guess, that's an assumption. All right, not enough information. Whenever we say not enough information given, that's an assumption. All right. Okay, now you get to do it. Practice 3. Go ahead and answer those and pause me and come back. Okay. Which statements cannot be assumed? A and C cannot be assumed. All right. Did you struggle with anything in this lesson? If so, how did you deal with it? Make sure you are checking in with someone, with your table partner, with a teacher. And go work in ALEKS.